Hello students, today we're going to do a little intro to perimeter, circumference, and area. Please don't forget to take notes as you go and complete the survey that follows. So let's look at some key definitions. The first is, what is perimeter and circumference? Perimeter is the distance around a figure, while circumference is the distance around a circle. So perimeter is for our figures or our polygons, and circumference is specific to a circle. And then the area is the amount of surface that is covered by a figure. So keep in mind that perimeter, circumference, both of those are measured in units of length. So for example, we can just say meters, or we can just say feet. However, area uses square units, such as meters squared and feet squared. And you can see in our abbreviation for these, we have the little exponent of 2 to indicate that we have ourselves feet squared or meters squared. So let's look at 4 different types. We have ourselves the square, rectangle, triangle, and circle. So you may or may not be familiar with these already. So let's first look at the square and look at the perimeter and the area formulas. So since the square has all equal sides, we know that we can say the perimeter is s plus s plus s plus s, but that's quite a bit. So we can just say it's 4 times the length of s because they're all the same. And then the area is side times side, and then s times s is s squared. Continue on to the rectangle, which we could also use for our square. Since we know that the opposite sides are going to be equal in a rectangle, so for example, we know that this side is length L, and this is our width here. We can add them all up, W plus L plus W plus L. However, it can be shortened to 2L plus 2W. And then to find the area will be length times width. The triangle, we don't have any special way to indicate the length, so we know that the lengths are A, B, and C in this specific diagram. So to find the perimeter, we would add them up. However, our area is 1/2 base times height. Now look at the height in this one is inside the triangle, but that's not always the case. Sometimes we might have a triangle whose height is outside, so our height would be out here if it was an obtuse triangle, and we'll get into triangles a lot more later on down the line. Or we can have ourselves a right triangle, and in that case our height would be exactly on it. So the height could be inside, outside, or on the triangle depending upon the type of triangle we have. And then finally, our circle. We know the diameter goes from one side of the circle to the other, and it has to go through the center. And the radius is exactly half the diameter. So for the circumference, we can look at it 2 ways. We can use the diameter, in which case it would be pi times d, or we could use the radius, and that would be 2 times pi times r. Our area would be pi r squared. So in that case, we're just using the radius, and we don't have one for our with our diameter. And if you didn't know, pi is a ratio that compares the circumference to the diameter. That's how we get the number 3.14, so on and so forth. So now that we pretty much have a good understanding of what those formulas are already, let's go ahead and do a couple of examples with them. So the first one here we have is a basketball court. We want to find the perimeter and the area. So let's take a look. We know our length in this problem is 84, and we know that the width is 50. So we're going to use that in our formula. We know that the formula is 2 times the length plus 2 times our width. So substituting these values in, our length is going to be 84 plus our width here is going to be 50. So multiplying and adding them out, we get a total of 268 feet. Remember, perimeter is just in feet. Now let's find our area. Our area is found by multiplying length times width. So in this one, we're going to take the value of 84, and we're going to multiply it by 50. So we multiply 84 times 50, we get 4,200. And remember, with area, it's square units, so we're going to put a little exponent of 2 to indicate square units. All right, moving on to the next one here, we're going to take a look at it. We have a triangle QRS whose vertices are 1, 2, 4, 6, and 5, 2. Now, please bear with me as it is a little bit difficult to put these points on there, so I'm just going to go ahead and draw. I know that one point is here at 1, 2. The other one is at 4, 6. And the last one, oops, see that disappeared. The last one is at 5, 2. So this is Q, R, and S. So if I connect the points here, I need to go through and calculate my values. Now QS is a horizontal line, so I can just count 1, 2, 3, 4. So I know the length of QS is equal to 4. And the reason I'm doing it is to find perimeter, I need the length of all the sides. So now I'm going to find the length of QR. So I'm going to use the points Q and R, and I'm going to use the distance formula to calculate it, because you can't just count these. So for this one here, if I were to subtract the x values, it would be 4 minus 1. And remember, I square it, plus 6 minus 2. And again, remember that I square it. So 4 minus 1 is 3, square it is 9. 6 minus 2 is 4. Square root is 16. Add them together, we get 25. Square root of 25 is 5. So I know the length of QR is 5. Repeating that same process for QS using the distance formula, I found that that length is the square root of 17, which is about 4.1 units. So if I want to go through and find the approximate value, I'm going to find the perimeter by adding those three up, which would be 4 plus 5 plus 4.1. So we know that the approximate value is 13.1. And we don't have specific units, so we're just going to use the word unit. And in our last example here, an ice resurfacing machine is used to smooth the surface of the ice at a skating rink. The machine can resurface about 270 square yards of ice in 1 minute. But how many minutes does it take the machine to resurface a rectangular skating rink that is 200 feet long and 90 foot wide? So the first thing we need to do is find the area of the skating rink. So in this one here, we know the length is, as it says in here, 200 feet. And the width is 90, so to find the area, we will multiply 200 times 90. And what we end up is 18,000 feet squared. Now keep in mind, when we went through up here, it says it can do 270 square yards in 1 minute. So when we want to calculate how long it's going to take, we need this in terms of minutes. So what I want you to think about is if I were to do square yard, 1 yard is equal to 3 feet. So if I want to know how much is 1 square yard in terms of feet, well, 3 feet by 3 feet is 9 feet squared. So what I can do is I can do 18,000 and divide it by 9, and I would get 2,000. That means our 18,000 feet squared represents 2,009 squared, or yards squared. What I would like for you to do is finish this problem and complete it in the survey, or give me your answer in the survey. If you have any questions, write them down and bring them to class tomorrow. Please make sure you complete the survey at the end of the video.